Next we have these limits which are of the form limit x tends to a fx to the power gx. Now in this limit we have three standard indeterminate forms, and which are 1 to the power infinity, 0 to the power 0, or infinity to the power 0. Now in such questions what we'll do is we'll write this as this limit x tends to a and then e to the power log fx to the power gx. Now we can take this power out, so it will be this limit x tends to a e to the power gx into log fx, and since exponential function is a continuous function, we can take this limit inside, so it will be e to the power and then this limit x tends to a gx into log fx. So in all the questions where we have function to the power function, we will be writing it in this form. Now we take an example. Say we have this limit x tends to 1 negative 1 minus x square to the power 1 upon log 1 minus x. Now this is 1 minus 1 0, and it is 1 upon log 0, which is infinite, so it is 0 to the power 0 form, which is an indeterminate form. Now we can write this limit as this limit x tends to 1 negative e to the power log 1 minus x squared to the power 1 upon log 1 minus x. Now we can take this power out, so it will be this limit x tends to 1 negative e to the power log 1 minus x square upon log 1 minus x. Now since this exponential function, it is continuous, we can take this limit to the power of e, so it will be this e to the power limit x tends to 1 negative log 1 minus x square upon log 1 minus x. Now we put x as 1, this is log 0 is minus infinite, and here also it is log 0 minus infinite, so it is infinity upon infinity form, for which we can use L'Hopital's rule. So it will be this e to the power limit x tends to 1 negative, and this is 1 upon 1 minus x square into minus 2x, and here it will be 1 upon 1 minus x into minus 1. Now here 1 minus x will cancel, so we can add this as e to the power this limit x tends to 1 negative, and this is 2x upon 1 plus x. Now if we put x as 1, it will be simply e to the power 1. So answer to this limit is e. Now of these three forms, the form which is mostly used is this 1 to the power infinite form. So this 1 to the power infinite form is the form which you have to come across more often than not. Now we can solve this 1 to the power infinite form in this general way, and then we have a shortcut for 1 to the power infinite form. Now shortcut for 1 to the power infinite form is, if we have this limit x tends to a fx to the power gx, and it is 1 to the power infinite form, then we can simply write this as e to the power this limit x tends to a, and then we write gx into fx minus 1. So all we need to do is we have to write this as e to the power this limit x tends to a gx into fx minus 1. So basically what we are doing here is we are using the standard limit 1 plus x to the power 1 upon x, it is e. So what we have done here is we have written this as limit x tends to a, and this is 1 plus fx minus 1. Now we'll multiply and divide everything with fx minus 1. This limit x tends to a fx, it is 1, and limit x tends to a gx is infinite. So this is 1 plus x to the power 1 upon x, And we know that this limit, when x tends to 0, it is e. So this limit will be e. So we can simply write this as this limit x tends to a e to the power fx minus 1 into gx, and hence this shortcut. But this one thing you have to keep in mind is it is only applicable in the case of 1 to the power infinite form. So if you are going to use the shortcut for any other form, it won't give you the right answer. But if the limit is of the form 1 to the power infinite, mostly we'll be using this shortcut. Say for example, we have to solve this limit x tends to 0, a to the power x plus b to the power x plus c to the power x upon 3 whole to the power 1 by x, where a, b and c, they are greater than 0. Now if we put x as 0, this is 1 plus 1 plus 1, 3 upon 3 is 1, and 1 upon 0 is infinite, so it is 1 to the power infinite form. And if it is 1 to the power infinite form, we are directly going to use the shortcut, so it will be e to the power this limit x tends to 0. Now gx is 1 by x into fx minus 1, so it will be a to the power x plus b to the power x plus c to the power x upon 3 minus 1. Now we can rewrite this as e to the power this limit x tends to 0, and this is a to the power x minus 1 plus b to the power x minus 1 plus c to the power x minus 1 whole divided by x. And then we also have this 1 by 3. Now all these three as standard limits, this is log a, this is log b, and this is log c. So it will be e to the power 1 by 3, and this is log a plus log b plus log c, which is log abc. Now we'll take 1 by 3 to the power of abc, so it will be e to the power log abc to the power 1 by 3. Now this e and log will cancel, so answer to this limit will be abc to the power 1 by 3. So this is how we are going to solve the problems of the form 1 to the power infinite.
Now here the question is, we need to find this limit x tends to 0 cos ax to the power cosec square bx. Now we put this limit cos 0 is 1 and cosec 0 is infinite, so it is 1 to the power infinite form. And for this form, we have the shortcut that we can write it as e to the power limit x tends to 0. Now this is cosec square bx, and it will be cos ax minus 1. Now we'll write this as limit x tends to 0 minus, and then we'll write this as 1 minus cos ax into 1 upon sin square bx. Now we'll multiply and divide it with a square x square, and here we'll multiply and divide it with b square x square. Now this is standard limit, which is 1 by 2, and this is standard limit, which is 1, and x square will cancel. So answer to this limit will be e to the power minus a square upon 2b square, and that's your option C. Now the question is, if alpha and beta are the roots of this quadratic equation, then this limit x tends to alpha 1 plus ax square plus bx plus c to the power 1 upon x minus alpha. Now since alpha is root of this equation, this expression will be 0. So this is 1, and then 1 upon 1 minus 0 is infinite. So this is 1 to the power infinite form. We can write this as e to the power limit x tends to alpha, and then gx, which is 1 upon x minus alpha into fx minus 1, which is ax square plus bx plus c. Now we know that we can write this quadratic equation in factorized form. So we can write this as a into x minus alpha into x minus beta upon x minus alpha. Now x minus alpha will cancel. Now we'll put x as alpha, so it will be this e to the power a alpha minus beta, and that's your option C. Now here the question is, we need to find this limit when x tends to 0. So this is L and LB. This limit x tends to 0, sin x to the power 1 by x, and plus this limit x tends to 0, 1 by x to the power sin x. Now this is 0 to the power infinite form, and this is infinity to the power 0 form. Now basically 0 to the power infinite is not an indeterminate form. So we'll actually write this as e to the power limit x tends to 0 log sin x upon x, and plus this limit x tends to 0 e to the power limit x tends to 0 sin x, and this is log 1 by x. Now first we'll check its form. So this is log 0 is minus infinite, and minus infinite upon 0 is actually minus infinite. So this is e to the power minus infinite, and e to the power minus infinite is 0. So value of this first limit is 0. That means this L is simply the second limit, which is limit x tends to 0, and this is e to the power limit x tends to 0. We'll write this as minus log x upon cosec x, which is infinity upon infinity form. Now we use L'Hopital's rule, so it will be this e to the power limit x tends to 0, and this is minus 1 by x, and this is minus cosec x into cot x. Minus and minus will cancel, so it will be this e to the power limit x tends to 0 sin x into tan x upon x. Sin x upon x is 1 and tan x is 0. So it will be this e to the power 0. That means value of this limit is simply 1. And that's your option C. Now here the question is, we need to find this limit x tends to 0 1 plus x to the power 1 by x upon e whole to the power 1 by x. Now we take this limit, 1 plus x to the power 1 by x is e upon e is 1, and 1 upon x will be infinite. So it is 1 to the power infinite form, and we know that there is this shortcut limit x tends to 0 fx to the power gx, and if it is of the form 1 to the power infinite, we can write this as e to the power this limit x tends to 0 gx into fx minus 1. So we write this as e to the power limit x tends to 0, and gx in this case is 1 by x, and then it will be 1 plus x to the power 1 by x minus e upon e. Now we can write this as this limit x tends to 0 1 by x. We'll use the expansion of 1 plus x to the power 1 by x. It is e minus ex by 2 minus e upon e. Now this e and e will cancel. Ex will also cancel. And when you put x as 0, higher powers will cancel. So value of this limit will be e to the power minus 1 by 2. Now this second question is this limit x tends to 1 negative 1 plus cos inverse x to the power 1 minus x has the value which is the following. Now in this what we'll do is we'll let x as cos theta. Now when x is 1, theta is 0. So from here we can say this theta tends to 0 positive. So we can write this limit as limit theta tends to 0 positive 1 plus theta to the power 1 minus cos theta. Now this is 1 and here it is 0 to the power 0 form. Now we can write this as 1 plus e to the power limit theta tends to 0 1 minus cos theta into log theta, and we can write 1 minus cos theta as 2 sine square theta by 2 into log theta, which we can also write as 1 plus e to the power limit theta tends to 0, and this is 2 log theta upon cosec square theta. Now this is infinity upon infinity form. So if we use L'Hopital's, we can write this as 1 plus e to the power limit theta tends to 0, and this is 2 1 upon theta, and here it is this 2 cosec theta by 2, and then cosec theta is minus cosec theta by 2 and cot theta by 2 1 by 2. Now we can write this as 1 plus e to the power limit theta tends to 0, and this is minus 2 sine theta by 2 sine square theta by 2 tan theta by 2 upon theta. Now we multiply and divide it with 2. This is 1 and sine 0 is 0. So this is 1 plus e to the power 0, which is 1 plus 1, and that is 2. So answer to this limit is simply 2. And that's your option B. Now here the question is, we are given this limit x tends to infinite a1 to the power 1 by x plus a2 to the power 1 by x up to an to the power 1 by x whole divided by n to the power nx. Now if we put x as infinite, a to the power 0 is 1, a2 to the power 0 is also 1, so it will be 1 plus 1 plus 1 n times, n upon n is 1, and nx is infinite, so it is 1 to the power infinite form. Now we can write this as e to the power, this limit x tends to infinite nx into a1 to the power 1 upon x plus a2 to the power 1 upon x an to the power 1 upon x whole divided by n, and then minus 1. Now we take this LCM, then we can write e to the power limit x tends to infinite nx, and here it will be this a1 to the power x plus a2 to the power 1 by x plus an to the power 1 by x minus n upon n. Now this n and n will cancel. Now we'll write this n as minus 1 minus 1 minus 1 n times, and we'll write this x as 1 by x. So it will be this e to the power limit x tends to infinite, it will be a1 to the power 1 by x minus 1 upon 1 by x plus a2 to the power 1 by x minus 1 upon 1 by x and up to an to the power 1 by x minus 1 upon 1 by x. Now this is standard limit. It will be log a1. Next one will be log a2 and log an. So it will be this e to the power log a1 plus log a2 plus log an, which is e to the power log a1 into a2 into an, which is a1 into a2 into an, this product. So answer to this limit is a1 into a2 up to an. And if we take a1 as 1, a2 as 2, an as n, then it will be 1 to the power 1 by x, 2 to the power 1 by x, n to the power 1 by x upon n to the power nx. That will be equal to a1 into a2 into a3 up to an. So it will be 1 into 2 into 3 up to n. In that case, answer to this limit will be factorial n. Now here the question is, we need to solve this limit x tends to 0 sine square pi upon 2 minus ax into secant square pi upon 2 minus bx. Now first we'll check its form. If we put x as 0, sine pi by 2 and sine pi by 2 is 1 and secant pi by 2 is infinite, so it is 1 to the power infinite form. We'll directly use the shortcut, so it will be this limit x tends to 0 and then it will be this secant square pi upon 2 minus bx into sine square pi upon 2 minus ax minus 1. Now sine square theta minus 1 is minus cos square theta, and we let the secant in terms of cos as well. So it will be this e to the power minus, and then this limit x tends to 0 cos square pi upon 2 minus ax upon cos square pi upon 2 minus bx. Now x square, it is a continuous function, so we can take this limit inside. So we can write this e to the power minus, and then this limit x tends to 0 cos pi upon 2 minus ax upon cos pi upon 2 minus bx whole square. Now if we look at this limit, this is cos pi by 2, which is 0, and denominator also it is cos pi by 2, so it will again be 0, so it is 0 upon 0 form. Now we can use L'Hopital's rule. Now if we use L'Hopital's rule, we can write e to the power minus, and then it will be this limit x tends to 0. Now differentiation of cos is minus sine, so it will be this minus sine pi upon 2 minus ax, and then it will be this minus pi upon 2 minus ax whole square into minus a, and the denominator will be minus sine pi upon 2 minus bx, and then minus pi upon 2 minus bx whole square, and then it will be this minus b whole square. Now if we put this limit, sine pi by 2 is 1. Now minus pi and minus pi will cancel. This minus and minus will also cancel. Now we put x as 0. This will be this 4. It will be this 4 which will cancel. So answer to this limit will be simply e to the power minus a square upon b square. Now here the question is, we need to find this limit, which is limit x tends to 0 positive, limit n tends to infinite, and then this summation r square into sine x to the power x greater than 0 function, where r varies from 1 to n whole divided by n cube. Now we can write greatest integral function of x as x minus fractional part of x. So it will be this limit x tends to 0 positive, and it will be this limit n tends to infinite, and then we can write this as summation r varies from 1 to n r square sine x to the power x upon n cube minus this limit n tends to infinite fractional part of r square sine x to the power x upon n cube. Now we know that any fractional part function, it will lie between 0 and 1. So therefore this summation r square sin x to the power x, it will always be greater than or equal to 0, but it will be less than n. Now we divide everything with n cube, and if we take this limit n tends to infinite, left hand side is 0, right hand side is 0, then from sandwich theorem we can say that the value of this limit will be 0. So in that case, this limit will be limit x tends to 0 positive, limit n tends to infinite, and this is sin x to the power x, and then summation r square, and summation r square is n plus 1 2n plus 1 divided by 6. Now this is infinite limit Now highest power of n in the numerator is 3 and highest power of n in the denominator is also 3. So answer to this limit will be coefficient of n cube in the numerator and denominator. So it will reduce to a limit x tends to 0 positive to sin x to the power x upon 6, which is 1 by 3 sin x to the power x. Now we have to solve this limit in x. So it is this limit x tends to 0 positive sin x to the power x whole divided by 3. Now this is 0 to the power 0 form. We can write this as 1 by 3 e to the power limit x tends to 0 x log sin x, or we can write this as 1 by 3 e to the power limit x tends to 0 log sin x upon 1 by x. Now this is infinity upon infinity form. Now if we use L'Hopital's rule, we can write this as 1 by 3 e to the power limit x tends to 0, and this is 1 upon sin x into cos x, and then it will be minus 1 upon x square. So this is 1 by 3 e to the power limit x tends to 0 minus this is x upon sin x and then into x cos x. X upon sin x is 1 and x is 0. So this is e to the power 0 and e to the power 0 is 1. So answer to this limit is 1 by 3. Now here the question is, we are given two functions and one of them is fx, which is this limit n tends to infinite cos x upon under root n to the power n. Now the first thing that we do in limits is to identify its form. Now when n tends to infinite, this is cos 0 is 1, and then to the power n is infinite, so it is 1 to the power infinite form. We'll use the shortcut directly, so it will be this e to the power limit n tends to infinite. Now this is n into cos x by under root n minus 1. Now we'll write this as e to the power limit n tends to infinite. We'll take this minus common. It will be 1 minus cos x by under root n, and we'll take this n in the denominator. So we'll write this as under root n square, and then we'll multiply and divide it with x square. Now this is standard limit. This is 1 minus cos x upon x square, which is 1 by 2. So basically this function fx will be e to the power minus x square by 2. So that's our function fx. Now we are given another function which is gx, and gx is minus x to the power 4b, where b is this limit. So we'll solve this limit. B is this limit x tends to infinite. Now we'll rationalize it. If we rationalize it, we'll write x square plus x plus 1 minus x square plus 1 upon under root of x square plus x plus 1 plus under root of x square plus 1. Now this x square will cancel. This 1 will also cancel. Now the highest power in the numerator is x, and in the denominator it is also x. So value of this limit is 1 by 2. And if b is 1 by 2, then this function gx, it will be minus x square. So we have our fx and gx. So fx is e to the power minus x square by 2. That's your option B. And gx is minus x square. Now it says number of solutions of fx plus gx equals 0. So we have to find number of solutions of fx plus gx equals 0. Now this is e to the power minus x square upon 2, and then minus x square equals 0. So you can write this as e to the power minus x square by 2 equals x square. So we'll use graph for this. Now if we draw the graph of e to the power minus x square, it will be this graph, and x square is parabola opening upwards. So these two graphs, they'll intersect at 2 points. Therefore, it'll have 2 solutions, which is your option A. So answer to this question is B, A and A. Now the question is, find a polynomial of least degree such that limit x tends to 0, 1 plus x square plus fx upon x square to the power 1 by x, it must be equal to e square. Now first we look at its form. It will be 1 plus 0 plus f0 upon 0 to the power infinite. Now it will be indeterminate form if it is 1 to the power infinite, and in that case we should have f0 as 0. And also minimum power of fx in this case should be x square, otherwise it will be this infinite form. Now if it is 1 to the power infinite form, we'll use the shortcut directly, so it will be this e to the power limit x tends to 0, 1 by x, and then x square plus fx upon x square. So it will be this e to the power limit x tends to 0, x square plus fx upon x cube. Now this should be equal to e square. Now this is x tends to 0, and in the denominator minimum power is 3. So in the numerator also, this x square plus fx, it should have minimum power 3 to have this non-zero finite answer. That means this x square plus fx, it must be of the form 2x cube to get this limit as e square. And since we are trying to find polynomial of least degree, we have discarded terms containing x to the power 4, x to the power 5. So we'll have least degree only 3. So in this case, this function fx will be minus x square plus 2x cube. Now the question is, we are given this limit x tends to 0, 1 plus x log 1 plus b square to the power 1 by x, it is 2b sine square theta, where b is greater than 0. Now this is 1 to the power infinite form. We'll use shortcut, so it will be e to the power, and then it will be this limit x tends to 0, 1 by x, and then x log 1 plus b square, and it is equal to 2b sine square theta. Now x and x will cancel. Now this is 1 plus b square equals 2b sine square theta, or we can write b plus 1 upon b by 2, it is equal to sine square theta. Now b plus 1 upon b by 2, it is greater than or equal to 1 using am and gm. Whereas, so this left hand side, it is 1 or greater than 1, and your right hand side, which is sine square theta, it is always less than or equal to 1. So the only case where this left hand side can be equal to right hand side is when both of them they are 1. And if both of them they are 1, then value of b is 1 and sine square theta equals 1 means theta is plus or minus pi by 2. That means this option D is correct. Now here the question is, we need to find this limit x tends to 0, 1 plus, and here it should be fractional part of x. So this is limit x tends to 0, 1 plus fractional part of x to the power 1 upon fractional part x upon e to the power 1 upon fractional part of x. Now if we find its left hand limit will be limit h tends to 0 positive, we'll take x as 0 minus h. So it will be this 1 plus 1 minus h to the power 1 upon 1 minus h upon e to the power 1 upon 1 minus h, which is 2 upon e. In this case, left hand limit is pretty simple, and it is 2 by e. Now we'll find its right hand limit. Now its right hand limit will be, if we take x as 0 plus h, and we know that fractional part of h is simply h. So
RHL will be limit h tends to 0 positive will be 1 plus h to the power 1 by h upon e to the power 1 by h. Now 1 plus h to the power 1 by h, it is e, and e upon e is 1. So this is 1 to the power infinite form, and for 1 to the power infinite form we'll use our shortcut. So it will be this e to the power limit h tends to 0 positive, it will be 1 by h, and then we'll have 1 plus h to the power 1 by h upon e minus 1. So it will be this e to the power limit h tends to 0 eh, and now we'll use the expansion of 1 plus h to the power 1 by h. Now this is e minus eh by 2 and then minus e. Now here e and e will cancel, so this value will be e to the power minus 1 by 2. So left hand limit is 2 upon e and right hand limit is e to the power minus 1 by 2. So this limit, it does not exist. Now here the question is, we need to find this limit x tends to 0, 1 plus x to the power 2 upon x upon e square to the power 4 upon sin x. Now this is 1 to the power infinite form. So again we'll use the shortcut. So it will be e to the power limit x tends to 0, and this is 4 upon sin x, and it will be 1 plus x to the power 2 upon x upon e square minus 1. So it will be this e to the power limit x tends to 0, 4 upon sin x, and here it is 1 plus x to the power 2 upon x minus e square upon e square. Now what we'll do is, we'll multiply and divide it with x. Now x upon sin x is 1, so we'll write this as e to the power limit x tends to 0, and this is 4, and we'll write this as 1 plus x to the power 1 by x whole square minus e square upon e square x. Now this is e to the power limit x tends to 0, and this is 4. Now we'll use the expansion of 1 plus x to the power 1 by x. So this is e, and then it will be 1 minus x by 2 whole square minus e square upon e square x. Now e square and e square will cancel. So we'll get this as e to the power limit x tends to 0. It will be this 4 into, and then it will be this 1 square and minus 2ab. So there will be minus x plus higher powers of x minus 1 divided by x. Now this 1 and 1 will cancel, x and x will also cancel. So value of this limit will be e to the power minus 4, and that's your option B. Now the question is, if limit x tends to 0, fx upon sin square x equals 8. Now it has to be 0 upon 0 form. That means f0 is 0, and also this limit x tends to 0, gx upon 2 cos x minus x into e to the power x plus x cube plus x minus 2. Now if you put x is 0, so it is 2 minus 2 0, 1 minus 1 0, so which again is 0 upon 0 form. This is lambda, and we also know g0 is equal to 0, and we are given that this limit x tends to 0, 1 plus 2 fx to the power 1 upon gx, it is e to the power minus 1. Now this is 1 to the power infinite form. If we use shortcut, we can write this as e to the power limit x tends to 0, 2 fx upon gx, it is equal to e to the power minus 1. So from here we can write this limit x tends to 0 fx upon gx, this value will be minus 1 by 2. Now we need to find the value of lambda. Now what we'll do is we'll divide these two limits. Now if we divide them, we can write limit x tends to 0 fx upon gx into 2 cos x minus x into e to the power x plus x cube plus x minus 2 upon sine square x, and will be equal to 8 upon lambda. Now we have already worked this out. This is minus 1 by 2, so it will be this minus 1 by 2 and then this limit x tends to 0. Now we write this as minus 2 1 minus cos x minus x into e to the power x minus 1 plus x cube upon sine square x, and it is equal to 8 upon lambda. What we'll do is we'll divide numerator and denominator with x square. So this is x square, this is x square upon x square. Now this is minus 1 by 2. Now 1 minus cos x upon x square is 1 by 2. So this is minus 1. Here e to the power x minus 1 upon x is 1. X will cancel. So this is minus 1 plus 0 upon this is 1. That is equal to 8 upon lambda. So clearly value of lambda is 8. And that is the answer to this question.